That RRM notebook which I have been telling you, where are you with that? That reactions, reagents and mechanism notebook. Keep transferring all these important things there in your own language. Yes? What are the 6-7 important things what I told there? The reactants, yes, or the substrates, first of all. Reactants or substrates you can call it. Your reagent, yes. Any conditions, external conditions required, some solutions or some heat or some acidic conditions, this, that, yes. What else? Name of the reaction, type of the reaction, mechanism of the reaction, explain the mechanism. That's all. If you're doing that in every section, every important reaction are being transferred in that one notebook, organic chemistry, nobody can touch you. You will be flawless. 100 out of 100. Yes? Please do that. Isomerization, where obviously the position of the triple bond will shift. This is another beautiful reaction. You take a terminal alkyne, heat it in the presence of alcoholic KOH, potassium hydroxide, sometimes even sodium hydroxide. Yes, heat it in its presence, and you will find the triple bond shifting and becoming but1-ine turns into but2-ine. Beautiful. Yes. Triple bond has shifted. So this is isomerization. Positional isomerism has taken place. Yes or no? Or in place of alcoholic KOH, use a stronger base than alcoholic KOH, which is sodamide here, correct? And heat it in its presence. You will again turn back, or basically isomerization will happen. If you have taken but2-ine, it will transform into but1-ine, and vice versa. If you take but1-ine, it will transform into but2-ine. Basically, these bases are going to cause isomerization at higher temperatures. Yes, sufficiently higher temperatures. Nice. Good. Another type of reaction. So what all we have seen so far? We have seen addition reactions, 2 types of addition reactions: electrophilic addition, nucleophilic addition. We have seen oxidation type of reactions happening here, and then we saw recently substitution reaction, then isomerization reactions. All these alkynes are undergoing. And then finally polymerization reaction. That means even triple bonds can also polymerize. Yes, they can, and this is called dimerization. For example, you take 2 moles of ethyne in the presence of cuprous chloride and ammonium chloride, correct? What will it form? It will form vinyl acetylene. This is called as vinyl acetylene. So one of the carbons of the ethyne attacks on another carbon of another ethyne. Both of them combine with each other. Obviously, since one of them is attacking on the other, H plus is substituted, correct? In place of that H plus, here now there is only double bond, here there is triple bond. So one ene and one ine are in conjugation with each other. This part is vinyl, so mono vinyl acetylene. Make sense? Yes, this is vinyl. I hope that part is clear. Good? Any doubt? Very good. Example is taken here. Further, if you treat it with hydrochloric acid, what will happen? Chlorine will substitute one of the triple bonds and will join there. Which type of reaction is happening here? When HCl is coming close by, which type of reaction is happening? Electrophilic addition. Yes or no? Cl coming here, H plus going on the terminal carbon. Yes? Yes, electrophilic addition is happening. Next, now this is in a condition to polymerize. Why? Because double bond has come. Initially it was not, by the way. Initially it only formed a dimer product, which we can call as a kind of linear polymerization, but fine, only it forms dimer. After that, when you expose it to a acid like HCl, you will have chloroprene formation. What do we call this? 2-chloro-1,3-butadiene. We call it chloroprene in short. This chloroprene, when polymerizes, this is the monomer. The polymer which it forms is known as neoprene, which is used in the synthetic rubber. Yes, which is used as synthetic rubber, neoprene. Make sense? Correct? After this step, addition polymerization will take place. I hope that part is clear. You remember addition polymerization? The double bond used to break. Remember? If there was a double bond in an ene, what used to happen in the next step? This double bond will break, correct? It will combine on both the sides. Yes or no? It will combine on both the sides with the another alkene, thereby forming polymers. That's why we used to show it like this. Yes or no? Correct? Nice. Okay. 3 molecules of acetylene also can come together, again same way, forming this. This time both the hydrogens on the middle ethyne will be substituted by both the sides. The vinyl group will be there. So what will you call it? Vinyl this side, vinyl this side. It becomes divinyl acetylene. Nice. Cyclic polymerization is also possible, which is also called as cyclization also in short. Yes. So in cyclic polymerization, what will happen? Put it in a red hot, sometimes iron tube or copper tube at very high temperatures. That's why red hot it is written. Bring them together, they will form benzene ring. 3 moles of ethyne will form benzene ring. Yes, 3 moles of, if you take propyne, what will it form? This CH3 will remain out of the ring, and these 6 of them, 2 of in each molecule, will participate to form a benzene ring, which is known as mesitylene. Remember, we saw this in our aromatic compounds list. Good. I hope that list is still there on your wall as a mind map. Is it there? I hope you're going through it. These names come directly. That's the reason I've made everything very systematic for all of you. Anytime you go through this aromatic compounds, have a look on that sheet. Keep seeing them. Each one from that sheet should be in your mind. And unless until you see them, you cannot map it in your mind. That's why they're called mind maps. Yes or no? Keep seeing them regularly. Good. Then if you take this, every time at every carbon there will be one methyl group. Nice. Hexamethyl benzene. Good. Okay. Now similarly, in place of, let's say, using a red hot iron tube or red hot copper tube, if you go for triphenyl phosphine along with nickel carbonyl group, yes, then what will happen? Nickel carbon monoxide, if you react with that along with triphenyl phosphine, yes, TPP in short, triphenyl phosphine. In the presence of TPP, again benzene will form, 90% yield will be there. If you use 4 of them and Ni in the presence of NiCN whole twice, this time you will have cyclooctatetraene. Good. Some other reactions apart from these categorized reactions. Obviously, everybody will have some reactions here and there happening apart from these categorized reactions. So one of the most basic one is, in the presence of ammonia gas, expose this acetylene to electric spark, you will have 2 moles of hydrogen cyanide. Good. Expose it to higher temperature, you will have pyrrole formation. We have seen pyrrole. Yes or no? Correct. Expose it to HCN in a raw red hot iron tube, you will have pyridine formation. The moment you put it in a red hot copper tube or red hot iron tube, what happens? Aromatization happens, cyclization happens. Yes or no? Correct. Similarly, if you expose it to, do you remember this fellow, CH2N2? Do you remember CH2N2? Carbene formation happens from here. Yes, we have seen it in the, I'm telling you, whatever I'm teaching, that's why I was telling, when I taught you GOC, I took so much time. The reason was, while I was teaching you GOC, I kind of completed the whole of organic chemistry once. Everything is coming from there. Yes, the substrate which it will give, the reaction intermediate which it will give rise to will be carbene, which will be participating in the reaction. Correct. Nitrogen gas will be given off by this. The carbene will attack and will form cyclopropene. Further attack will form a bicyclo-110 butane. Make sense? 1 carbon here, 0 in the middle. So 110 butane. Total 4 carbons. Yes? Any doubt? We have seen this reaction already. Do the same reaction in the presence of cold ether solution. You will have this formation. Expose it to hydrogen gas, pyrazolene. Is that clear? Is that clear? This is pyrrole only, our pyrrole, which you have seen above. Yeah, this is pyrrole only. So pyrrole turns into, in the presence of hydrogen gas, the double bond breaks. One of the double bonds, CH2 formation will happen. This is pyrazolene. Yes. Sulfur in the presence of alumina at 400 degrees Celsius. So at the surface of alumina, the reaction happens in the presence of sulfur. Then thiophene formation happens. As you can see here, 2 moles of ethynes are actually coming together, and one side they are combining with sulfur, and the other side they are combining with each other. Do you see this? How they are forming actually? These are actually coming from our base material. What is that? Ethyne, acetylene. Yes? Okay. Another reaction is, which is called as ethynylation. If you expose our ethyne to, let's say, HCHO, which is formaldehyde, in the presence of a metal like copper, propyl alcohol is formed. Now, what is that propyl alcohol? One of the H plus gets substituted by CH2O here. That H plus later on is combining here as CH2OH. So alcohol formation happens. Good. Another molecule, if you bring it, on the other carbon also it will substitute this H plus and it will combine there as CH2OH. What do we have now? A diol formation along with an ine. Yes? Is it clear? Yes? Propyl alcohol, and then more exposure will produce more of this. Good. Next, NaOCl substitution reaction. Here also substitution reaction will happen. One of the Na plus will go. Who will join there? ONA. The H plus leaves and Cl plus this time joins, because oxygen is more electronegative than carbon. See here, this is a very special case. This reaction has to happen in the absence of air and light, because if you expose it to light, free radical formation will happen. Expose it to air, further oxidation will happen rather than substitution. And what do we want? We want substitution. Yes or no? We want substitution. Yes or no? We don't want any other thing happening here. And for substitution to happen, we keep it at a 0 degree Celsius in the absence of air and light, no heat also, that's why 0 degree Celsius. Then what will happen? Oxygen being more electronegative than chlorine, what will it do? Cl plus will go and substitute H plus. Cl joins there. And NaO minus combines with that H plus, forming NaOH. Easy peasy? Understood? Yes? Is this clear? Exactly same thing happening here also. Yes? If you expose it to one more molecule of that, dichloroacetylene formation happens. Good? Are we good? The same thing came here basically. You know? Okay, done. With this, we have completed today the chemical properties of alkynes, all the type of chemical reactions alkynes undergo. One of the last few two important things. One is usage. What are the usage of acetylene? One of the things which we already saw. It is used as oxyacetylene flame in welding and cutting. Correct? It is also many times used as an illuminant. Yes, produces bright white light. And it is also sometimes used exactly as alkenes. It is also sometimes used in artificial ripening of fruits. Yes? Apart from that, we can produce all the different things which we saw above. We can produce acetaldehyde, acetic acid, we can produce ethyl alcohols, Vestron, a polymer we saw above. Remember? Vestrosol it can produce, polyvinyl chloride it can produce, polyvinyl acetate it can produce, chloropene, neoprene, butadiene, lewisite, all that can be produced with acetylene. And we have seen the reactions of all these above. Yes or no? Apart from that, it is also in minor amounts used as general anesthetic. Yes, during surgeries and all that. Yes, now I don't know nowadays whether it is so much prevalent or not, but I think in mild amounts they are still being used, because chloroform is dangerous for our kidneys. So they have switched on to these type of things. I don't know in how much amount, that I'll have to check. Yes. Apart from that, few of the laboratory tests which we saw for alkynes. One thing was Bayer's reagent. I hope you remember what is Bayer's reagent. Cold alkaline dilute camenophore. Remember? Cold dilute alkaline camenophore. Yes. Which has in the beginning pink color, and it will disappear as soon as the reaction happens. Correct? You will have diol formation happening. Yes or no? Correct? This used to happen with the double bond also, and triple bond also it gets further oxidized. That's all the thing which happens. Yes. Then bromine water also, red color will decolorize because unsaturation is present. And similarly, ozone also will behave here. Acid formation will happen. Remember, we have seen all these things. We have seen hydroxylation, we have seen bromination, we have seen ozone lysis also. Good. Then apart from that, we also saw a laboratory test for terminal alkynes. Yes or no? We saw that also. Remember? Tollens reagent, ammoniacal, cuprous chloride, all that. Good. Acetylenic hydrogen is being detected, which you will find only in case of terminal alkynes. Good. What are the reactions? Cuprous chloride, ammoniacal cuprous chloride, red precipitate formation, or ammoniacal silver nitrate, which is also known as Tollens reagent, producing either silver precipitate, some places, rare places, it is also written as white also. Yes, silver or silvery white precipitate. Good. Because the test tube inner walls gets coated with that. Or sodium in the presence of ether produces a colorless gas, which is nothing but our hydrogen gas. Yes. All these can detect acetylenic hydrogen, that means triple bond at the terminal carbon. Good. Are we good? Yes. Decolorization of bromine in CCl4 solution is also possible. Decolorization of 1% alkaline camenophore solution. And one alkyne gives white precipitate with ammoniacal silver nitrate, silvery white. Yes. With ammoniacal cuprous chloride solution also. Are we good? Out of these two tests, decoloration in bromine in the carbon tetrachloride solution, or in the second one, decoloration with 1% Bayer's reagent, correct? That is determination of unsaturation. Yes. But test number 3 is what? Distinguish between terminal alkynes and from the other alkynes, non-terminal alkynes. Good? Are we clear? Yes. Sometimes, let's say they give you a test tube which is filled with ethane, ethene, and ethyne. How do you kind of separate them? First thing first, pass them through the ammoniacal cuprous chloride solution. What will happen? What will happen? You will have a red precipitate of cuprous acetylide formation happens. Yes. Once that happens, copper acetylide formation happens. Expose it to potassium cyanide, CuCN will form. You will have ethyne separated. Nice and easy. You still have a mixture of ethane and ethene. Expose it to concentrated sulfuric acid, ethyl sulfate will form. Heat it, ethene gas will come out. Ethane, you know, nobody can react with ethane other than free radicals. Ethane remain as it is. That's how it is separated. Nice. Remember this is very nice thing actually, especially not just from the point of view of JEE mains and NEET examination, also or any competitive examination, also from the point of view of board exams. Also from the point of view of board exams, it's also very important. Yes. How do you separate ethane, ethene, and ethyne, alkane, alkene, and alkyne? Nice. Done. And with this, the chapter is over. There are some of the solved examples. I want you all to go through this. Yes. Good number of solved examples are there. I think some 10-15 good number of solved examples are there. Go through them. That's all with this chapter, alkyne. Next, what we are starting, we'll be moving on to the alkyl halides and aryl halides. You have heard about them? Alkyl and aryl halides. What are aryl halides? The ones with benzene ring, aromatic compounds, substituents. Yes? Yes? Okay. Good. Fine.